And I think sometimes there's this perception that if you're not writing a document or you're not kind of
Yeah.
writing a lot of work that actually sometimes getting people around a whiteboard with a pen and going, right, what do we think this is actually really undervalued. And for me, it's one of those things. I mean, they joke at work. I love a good whiteboard, but it's like, well, but this is if you do this and get everyone on that same
Yeah.
page before you start, pays dividends.
We're live. Vicky, welcome to the SOSE Masterclass. Please give a small introduction to yourself and your very esteemed background.
Lovely. Well, thanks, Connor. Thanks for having me. So I'm Vicky Anderson, and I graduated about 17 years ago, which is a little bit scary. I don't quite know where the time's gone, but currently I'm working as a systems engineer in the space industry, and have done now for actually more majority of my career now has been more in space than in systems, but I actually sort of started life as an electronics engineer. So if I think all the way back to college, and I remember applying for my subjects, and I did get told at the time, oh, you've applied for a lot of boys subjects, and I was a bit like, oh, didn't really think they were boys subjects, but okay, fine. And but yeah, went to university, did electronics engineering, and then when I graduated, sort of went into the defence domain, so work as electronics engineer. And because at the time, I say this is a little while ago now, I didn't really have that perception that you could work in space in the UK. I thought that was a bit of a pipe dream. You saw like the NASA and the ESA, but I didn't really think there was much other than that. But the opportunity came to go work in the space sector, which I jumped at. So I did a number of years as an electronics engineer in the space domain, and I've got some bits flying around in space, which is really neat. And then I started to find that I was interested in the bits more than sort of the widget that I was working on, and it became apparent to me over time that actually systems would be a really good fit. And so I then sort of left the space domain for a little bit to go work back in the defence sector, but this time as a systems engineer. And so that was my first like official go at being a systems engineer. And I was fortunate enough, whilst I was at that company, to be sort of sponsored to go do a postgraduate diploma in system engineering for defence capability.
Yep.
So it was really nice to get some kind of academic, qualifications. Because actually, I am doing this, and I do know something about what I'm doing. So yeah, and then I had the opportunity to go practice as a systems engineer in the space domain, and that for me was kind of the rounding of the circle. That took me from kind of my early interest in space, through to kind of also having this interest in systems. So that the two came together nicely.
Very nice. I'm very sorry. I've actually just had another camera failure.
No, no worries.
That's actually really interesting. So you've actually transitioned from a purely electronics role across into the systems role. Why? Why did you choose systems?
Well, I don't think I actually consciously. Oh, it sounds really like what's the word, cliche, but I think it almost sort of chose me. I didn't realise. So when I was looking at what to do at university, and I say I was fortunate when I was at college. I got the opportunity as a part of an initiative to get more women into engineering, to spend a week at Bristol University, and whilst we were there, we had a number of lectures and different companies and kind of placements and stuff that we went and did, and we covered like the traditional, so like mechanical, electronics, computer software, those kind of things. So those kind of very applied engineering, I guess, roles. And so from that, went, oh, electronics, that's good, and that's how I went on to do electronics. But systems wasn't really talked about. It wasn't something that I ever kind of had been told about when I was at college or even at university. It just wasn't something that came up. So I hadn't really appreciated it when I joined like the workforce, that there was this overarching, I guess, discipline that went around engineering. And it wasn't until I was in my first job, and there was this whole team of systems engineers. And I remember when I was on my graduate scheme, I said, oh, I want to do a rotation through this department because it was this completely new thing, and I wanted to know a bit about it. And
Yeah.
so yeah, so that I found that really interesting. I think that kind of put a little bit of a spark of like, oh, there's this other area. But I mean, for a number of years, I was very much an applied engineer. I was doing FPGA design, so I was right down to, the logic, ones and zeros, very, very applied. But I like variety and I like change. And so after having done sort of the same thing for a number of years, I started to get, I don't want to say itchy feet, but that I would start looking, I guess, over my wall, like beyond what it was that I was doing in my section. And I started to realize that I actually had interests that were broader than what was within my direct sphere. And so and interestingly, not everyone else did. So it meant in a lot of projects and a lot of kind of programs and things that I was working on, I sort of de facto became some of the glue between some of the different sections and some of the different bits and pieces. And then it's kind of reminded me of that very early rotation I had through the systems department, right back when I was a graduate. And I thought, actually, this is a role and this is something I can do, and actually is something I'm interested in and have an aptitude for. And so that's when it really kind of made me go, do you know what, this gives me that breadth, that variety that I'm looking for, but also a real way to impact change. So that was a real kind of turning point for me to move over into systems.
That's really cool. I like that impact across change and actually seeing the whole picture type thing. That's really powerful. Now we understand why system engineering. Tell us why space. Why space? Why have you chosen space right now, right? Or why have you transitioned out of defense into space? And well, I guess they're closely overlap, aren't they?
Yeah, if you said tomorrow I could go in a rocket and go into space, I would bite your hand off. Like I would be there. For as long as I can remember, I've really like space, like everything to do with it. I think I'm in awe of the technology and the kind of skills that have been required to actually break into that environment, with the various kind of harshness that comes, with space and the like. And I'm a bit of a sci-fi, nerd as well. So it's always been an interest of mine. But like I said, I never thought it was something that I could do. When I was younger, space to me meant like astronauts or NASA or ESA, and I just assumed, well, that's not open to me. It's not going to be something I can do. So I'll do something else. And so hence, going into the defence domain as opposed to the space domain. But the market in the UK has like massively opened up, and probably it was a little bit of ignorance on my side, actually not realising even back when I graduated, actually how much space there is in the UK. And now, I mean, it's grown phenomenally. You've got a lot of the big players, but you've also got like a lot of small startups and things, and it's a really agile environment. And actually, the UK is at the forefront of a lot of it, which is really exciting. So I think it was just initially it was just that little piece of me want to go like, oh, I've got something in space. It's kind of neat to think there's something up there, that's doing things, and I did that, because I mean, ultimately I'm an engineer because I like to be able to point to things, say I did that, I've made a difference and I've done that. There's a tangible thing. I can't really point at the things that I do now; they're a little bit high, but I can see the tangible outputs, like the photographs that satellites are taken, or the data that people are getting to use to do neat things. And so that's really kind of where it's come from. So it's just satisfied the nerd in me who wanted to do space things, it's been and I think as well, if you've got a good grounding in engineering and systems, you can apply that to any domain, any project, because it's those underlying skills are the same. It's just learning the particular nuances of that that different domain. So I think it's been different, but it's transferred across nicely as well. So
yeah. And you've been around since like the emergence of space in the UK. I'm saying you've been around. It's not as if you're that old, but your career, right? So like you said, 17 years. A lot has happened in like the space sector. Okay, it's not all you haven't all been in space, but like the transition over the last 8 years has been pretty crazy actually. If we went from
I mean, if you think about kind of when I graduated, there was no UK launch capability,
Yeah.
for
Yeah.
example, and by the next year or two, there's going to be multiple UK launch capabilities. The UK is really looking at becoming like almost like a one-stop shop, right? Because it
Mm.
used to be, so for a long time the UK's been at the forefront of like the small satellite market, like
Yeah.
but always had to outsource to launch. Well, very soon, that infrastructure in the UK is going to be there, and
Mm.
it's also, and I think I always have to remind myself, it's not just the engineering in space that's growing. It's the practical physical engineering, but there's also all that downstream piece about the data and the applications and what that's opening up as well, and that's massive too.
Yeah.
So there's that full range piece, which I think is really growing and will
Mm.
continue to grow as more things become available.
And have you seen systems engineering sort of grow and expand over the last couple of years within space, or has it always typically been there?
I think space is an interesting one. I think as things have become so I think it's a little from column A and a little from column B. Space is, as you can imagine, very mission focused. You have a defined start and a defined end, and a group of things that have to happen in the middle. So I think there's always been a lot of structure around kind of the way missions are approached and the way
Yeah.
engineering is approached in space. I think some of the differences is space is now starting to look at and starting to feed in. There's a limited pot of money, right?
Yeah.
So although space industry is growing and there's lots of people kind of looking to get into the industry and the like, there's still only a finite pot of money. And so that money, in order to support the ecosystem, has to be able to go further or be used
Mm.
more efficiently. And so there has been, and I've noticed this, and it's something also at my company we're also looking at, is are there things that are done well in other domains, such as
Mm.
aerospace or maybe rail, travel, those kind of things, that we can leverage and bring back into the space industry to
Mm.
help with some of those efficiencies? So, and you've probably heard this term several times back on a digital twinning. Digital twin, like what
Yeah.
can we do? Because a massive part of space, right, is that verification validation piece. How do you know what you're going to do is going to work on the ground? You can't emulate, well, you can emulate aspects of the space environment, but you can't do the whole thing. It becomes very expensive and very kind of onerous. So
Yeah.
are there things that we can leverage from other industries to bring down some of those price points, to kind of
Mhm.
move the money around in different ways to kind of keep this market, open up this market more, as I said, which will
Yeah.
bring more opportunities. So I think that's a big change, because there's been a lot of, well, we've done this for however many years and we've always done it this way, so why would we need to change? And now there's a shift, I think, in the market to go, actually things need to change, because otherwise you
Yeah.
can't sustain this growth. So I think that's probably the biggest thing that I've noticed. Yeah.
Yeah, and I guess you get one chance to get it right as well, don't you?
Yeah, yeah.
You don't get a chance to go back and fiddle with it after it's kind of in service type thing.
No,
It's kind of you get, yeah,
no,
right
not.
first time is
Yes,
really
yeah.
important.
I mean, there are some interesting things looking at kind of in orbit servicing and the like. But yes, very much, it goes up, and you've got to hope
Yeah.
that it does what you want it to do when it gets there. I mean, you look at some of the recent, I guess, like some of the lunar things that have happened recently. Where unfortunately, some have worked better than others, and they're talking about kind of countless years of work and phenomenal amounts of money to achieve that. And it all comes down to that one moment. Does it
Mm.
do what it's supposed to, or not? And it can make or break companies. I mean, that's the long and the short of
Yeah.
it. So yeah, so it's a really interesting industry to work in, for sure.
Yeah. That's really cool. And so how have you applied systems engineering, that's a broad question. I'll go more specific. Do you particularly use any systems thinking aspects that you wouldn't necessarily use in the space domain, or are you using, requirements in a certain way? Is there any particular aspects of system engineering that is really important for the kind of space domain?
I think. I mean, other than all of it, I think
Yeah.
I think
Yeah.
think about maybe requirements in the system thinking specifically. One of the things, though this is probably also true of other engineering domains as well, is that real considering more of your stakeholders than just the person who turns up with the money. So I
Yeah.
think there can be a tendency, the person who turns up with a checkbook, that they have their requirements, and that's that's the starting point. But in the space domain, it is a regulated domain, so you can make the best thing in the world, but if you don't get your license, it's not operating. And so, and then, like we've sort of touched upon this, got the environmental effects and those bits and pieces as well. So there's actually, I think, an interesting set of stakeholders and contexts that you have to kind of think about up front, beyond just getting focused on your widget. And I think so that's really key. And I think impressing that upon, and it's something I know I do with some of our junior engineers, and also with others that we talk to, is actually thinking beyond that stovepipe of the person with the checkbook. Is you've got to really, it's also, although your system may be working in isolation, you're going up into an area that is, I don't think crowded, but there are other elements there that you have no control over. So if we take the example of looking at low Earth orbit, there are multiple items which are in the same altitude, right? And so so if you just looked at the person with the checkbook, you wouldn't think about the fact that you might need to do collision avoidance. And that's becoming a really important thing to have in your pocket. So it's really looking at that wider context piece, and also looking at where the regulations, things are going as a whole, because there's a big drive, understandably and correctly, for the more responsible and sustainable use of space. So something that you design now may not pass muster in a few years' time. So there's also that piece of going, well, how do we deal with that as well? And so ourselves as a company, we're looking at developing a platform which is like generic, that could be used by, for a multitude of different missions, and is the basis for the next sort of 5 years or so. Well, you've almost got to have a crystal ball to look into the future to say, well, actually, where is that going? And so I think there's a really big piece about actually it's not to use space sustainably and responsibly. You have to do that upfront piece, and you're not just throwing something up that you hope will work. You're actually doing the diligence to have something you go, this will work, it provides utility and value, and it's worth the kind of environmental and other expenses to actually put the thing into orbit. So I think that's the key piece, is that just being cognizant of that bigger picture, because there's lots of different stakeholders in play. Someone else does the launching, someone else might do the operating, someone else is it's not just you do a part of it, aren't in control of all of it.
So how do you most effectively capture all those different needs? So like you said, you've got these different operating systems. Someone's doing launching, you might have to integrate. Where do you even begin to start capturing these?
Yes, that is a good question. So after a little lay down in a dark room. No, I mean, we and there's a multitude of different ways. But so and in part sometimes it comes down to as always, there's that complexity and timescale push that we always get on programs. But I think for us, we always start with some high level context diagrams, right? So what are we actually looking at doing? Who are the stakeholders? Who do we care about? So you'll see, if you ever see anything we generate, there's normally a whole bunch of, like, I don't call them like spider diagrams at the beginning, where you just to start, because just to capture and I'm a big fan as well of sort of pig in the middle diagrams, where you have your thing and you put your stakeholders and you go, what are they actually interested in? Why do I care about these people? So we tend to do a lot of kind of that real kind of systems thing, concepts kind of context piece at the beginning, but trying to capture that, and this is always the trick, right? It's trying to capture that in an accessible way. So you don't write a 30-page document that someone's got to go through and read. So we try very hard to do that in quite a graphical way. So sometimes we will formalize it in a model-based system engineering tool. Other times it will be a PowerPoint with just the graphics, and it really depends on kind of, say, complexity of the project, how much time we have, and so on and so forth. But that is, for us, is always the starting point. We have in our office, we have a whole bank of whiteboards, and we literally, it's pen and paper, that's where we start, and I think sometimes there's this perception that if you're not writing a document, or you're not kind of writing a lot of work, but actually sometimes getting people around a whiteboard with a pen and going, right, what do we think this is actually really undervalued. And for me, it's one of those things. I mean, they joke at work. I love a good whiteboard, but it's like, well, but this is, if you do this and get everyone on that same
Yeah.
page before you start, pays dividends down the lines.
Yeah.
So
It seems like you've effectively reduced something highly complex, such as a satellite,
yeah,
down into a spider diagram, in a starts with a spider diagram. And I love how you've actually managed to reduce that complexity down to something as simple as, well, it's not a big hurdle that I have to overcome. We're just going to start by drawing on a whiteboard, and we're going to
yes.
figure out what people want. I love how you've reduced that barrier to entry. That thing it's really good.
Yeah, and I think it's probably so for a lot of things, but if you look at it, and it pains me, so I design satellite platforms for a living, and that's the bit that people aren't really interested in, right? Because it's the payload that does the cool whizzy bit, makes the money, and so on and so forth. But you need the platform else that doesn't point in the right direction. You can't get the data down, those kind of things. But if you boil a lot of these problems down, they very much follow a pattern. There's a space segment, a ground segment, there's a regulatory. So you can almost, before you start, kind of start with your generic, like, okay, I know it's got these things. Now let's look at maybe where it's different from others, where it's changed, and you can put that detail in. So it's because I think engineering, and you can probably test this as well, Connor, it's very rare that you start with a blank piece of paper, right? There's always something from before, or and I think we're taught a lot, especially when we're perhaps in academia, that you start from like a blank piece of paper, and you look, and actually a lot of the times you've got to deal with these other constraints that come in. And I think so we very much kind of look at, okay, what's the pattern of what it is, where does that vary from what we've done before, where do we have to go and do something different, and sometimes it might just be like, well, I've got a different ground station provider, so I just have to go check whether they have different constraints, and if you can then square that way, you go, great, now I know what that is, I don't have to worry about that anymore, I can concentrate over here where there's a lot of change. And I think that's the real sort of thing, that we try and break it down by. And I think you can apply that kind of pattern methodology to a lot of engineering, because if you look at it as guts, there's very few things which are radically different, unless you're right off in R&D land. Things tend to follow a similar pattern within a specific industry.
Yeah, and so talking about reuse then, so you mentioned model-based system engineering, and I don't want to go down the rabbit hole, but have you started looking at that concept, that digital twin, where you can pick it up really quickly and you can reuse it as opposed, and then kind of tweak it and create platforms and then go down that route?
Yeah, I mean it's something that we are looking at. So one of the big challenges is, I think. So within our company, we might employ some standards and we might be consistent. But what we would term standard, if we then went to another company, wouldn't be the same. And so I know that there are, I think there's a KISPE model that's been put together and things. But I'm always a little nervous about when someone says something is a standard, because sometimes when you scratch beneath the surface, it's not a standard at all, and actually it's very open to interpretation, but someone's put the word standard at the end. And we see this with some of the protocols and things that use, they're like standards, but actually the standard is more of a guideline. So someone can say, well, I use this and I use this, but these two things won't actually talk together, which is fun. But so we are looking at it, but there is this and if you talk to that, there's a lot of people saying, oh, well, you've used my product, it'll do. But actually, you're finding if you lift the hood on some of them, they're not as integrated as they might seem. And so, yes, we're very much looking at how we can use things like digital twins and model-based system engineering to our benefit, but very much looking at what is the thing we're trying to solve with that. So rather than going, I'm just going to put everything in a model because why not? It's go, well, actually, what do I want to solve in my modelling? So for me, I must admit, particularly, I like kind of modelling for that real concept and understanding people and what is it they want and getting all those needs together. But I must admit, when it comes to some of the latter parts, I would fall back to something else because it's more because it's easier for then the people that I need to engage with to get grips
on. Look at a physical document as opposed to
And so I think there's this sometimes a little bit of an all or nothing approach, and actually I think we need to be, there's more shades of grey than that. So I mean, the industry, I think, is tending that way, but I think there's still a lot to be done to actually come up with these fully integrated solutions. That means I can do something over here conceptually, which I can then directly trace to my physical implementation. I think there's still a bit of
Yeah.
a gap in some instances, but I think there are some really neat things, and say we're looking exploring some of these things, especially around some of the digital twin, to go, can
Yeah.
we model parts of our system to allow us to do, for example, computational verification rather than having to go and do an expensive test? Is there things and
Yes.
pieces that we can do
Yeah.
do there? So I say I think it's biting off bits that we can like chew, stop, and then look at, okay, now how do we pull these together to make a cohesive solution, rather than going, I've got a shiny tool and it does it all, because
Yeah.
I'm not convinced at that point. But that's just my opinion, and just based upon some of the things that I've seen.
Yeah.
Yeah.
No, I think it's a really good point. Is that where the industry is throwing around MBSE to the kind of the next thing, but actually when it comes down to the level below and actually
Yeah.
applying it and getting value out of it, you want to realize your system.
Yeah.
You don't want to just use MBSE because it's nice, but actually you
Yes.
want to kind of get to producing stuff.
Yeah.
I think, that's the next level down of actually, that doesn't really work here. And how does it work when we go speak to other people? And
Yeah.
it's
Yeah.
that's like the next level that I still think it's going to take a long time to get to that point where it actually works properly, right?
Yeah, and I think one of the sort of hurdles to this is, and I totally appreciate why it is what it is, but there's not a lot of good examples out there where someone has said, hey, I've done this thing and I've taken it from a clean sheet of paper all the way through MBS, and here is the solution, and you can see all that traceability. And I understand why, because if companies are working on products, there's a lot of IP in there, and so on and so forth. But I think it's really tricky, and I think a lot of companies end up kind of reinventing the wheel every time you want to do kind of something. Everybody has to almost go like, oh, well, what is it? Okay, well, let's do, and unless you work perhaps for some of the big primes or those kind of things, a lot of that's not there, and it's not accessible, which makes it tricky to sort of pick up and I guess know that you're doing it right, and that you're and so I think there's a bit to be said about how do we kind of, if it's something we think is, I think it does have value. I mean, I am an advocate for model-based system engineering for sure, and I'm not, but I think if you really want people to engage with it, you've got to make it more accessible, and you've really got to give people some real examples. Go, look, this is what you can do with it, and this is how you can actually engage with it, and look how powerful it is in these areas. Because I know we've all been on projects, right, where your project manager goes, well, hang on, we did this last time without it. You're telling me I should use this, but it's going to cost, because the setup costs, right? Once you've got it going, happy days, but the setup, and they go, why should I take the hit on my project for you to, when we've successfully delivered before? And I think having some examples of going to do that education piece is really what's going to take it from being like a nice concept that everyone says, yeah, we should do that, and digital twins, and go from being buzzwords, I think, to actually something that's just embedded everyday engineering,
But the learning curve to get to that point is massive, right? Because you essentially have to teach everyone a language and a tool and a methodology. And individually those are really big things just as their own right. To teach someone a language is going to take the guts of a year or 6 months to actually implement. So you're right. Why are projects going to turn around and say, I'm going to take all the load and I'm going to teach everyone this language and methodologies? It's like,
and that's why if we're doing some of this conceptual stuff and looking at these early bits, these early phases of the project, whiteboard and some pens, right? I don't mind I'm not going to say to someone, oh, no, you can't. Let's get that. It's more important for me for us to collectively get that shared mental model, all understand what the problem is, all understand where we're going. I can formalize that in a tool later. Like, I don't want, and I've talked in other forums about this before, about not letting that stifle that creativity and that thought, because people think differently, right? That's just it's a given. And like you say, if you try and say to someone, I want you to think about that, but also think in a language that you're not familiar with, suddenly your vocabulary reduces. So if you can say to someone, actually, here's a bunch of colored pens as a whiteboard, let's just, if it's a spider diagram, or if it's it's blobs with some squiggly lines, great, do that, and then I can, being someone who is fluent in inverted commas in the language, can then take that and formalize it. And then also people can then see how their random squirrels actually then translates into this language. I think taking
Yeah.
people on that journey makes it so much more powerful than just going here and they go, well, I can't engage with this. What
Yeah.
are you trying to get me to do? So I think there's a piece in that, but I like you say, expecting everyone to be fluent is really tricky.
Yeah.
So
Yeah. Okay, so coming back to the
yeah, sorry.
formalization, it's a,
Yeah.
it's a really no, it's a really good point. So formalization. So how do you go from essentially your context diagram on the
Yeah.
whiteboard to then a formalization of kind of those needs and that
Yeah.
kind of um,
So,
yeah,
so yeah, I mean, obviously, requirements are key to that, and I guess the other thing that we will run in tandem is sort of looking at so ConOps, so concept of
yeah,
operations. So we very much treat our ConOps as living documents. So at the beginning, very high level, you kind of go like, well, I know I need a thing, and it kind of needs to do this, but I don't know what
yeah,
blocks sit beneath those high level blocks,
yeah,
and we use that to kind of get agreement on, well, is this how we think we want it to work? And so before you're getting down into the the widgets and the ones and zeros, it's like, right, if I've got these big blocks and these people, is this how I expect data transfer? Who's interested?
yeah,
Why they're interested? So and then we would do our requirements alongside that.
yeah,
So we tend to take a very hierarchical approach to our requirements, very sort of standard and nothing, groundbreaking here, starting with those high level customer ones, then looking at maybe the system ones and the subsystem, and you go through and do that derivation piece, but keeping
yeah,
kind of your understanding and knowledge working, alongside it. We're not perfect as engineers. Even now, even though I'm a systems engineer, I still get excited by widgets, and sometimes
yeah,
we'll all leap off down a rabbit hole, and then we'll go like, oh, no, 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 we've got to come back up. And
yeah,
it's funny. There have been a number of programs where we've gone, whoop, we've gone too far. Actually, we have to go back and just close the loop on that top level
yeah,
stuff so that we know
yeah,
we're heading off in the right direction, or acknowledging that we're working at risk because some of that stuff is maybe not bounded out. But yeah, so
yeah.
yeah, for a
Two,
big
so
yeah
two things
yeah
on that note. So okay, so I love how you evolve the ConOps and actually
hmm
have the living document that you might come back to,
yeah
and then I like the point on working at risk.
hmm
How do those two things kind of evolve, and how when do you go back to evolve the ConOps, and when do you actually say no, we're going to work at risk and we're kind of going to go down based
yeah.
on might be a bit riskier?
I,
How do you go about that process?
yeah, that's a really good question. So we have so we follow a very traditional kind of review structure in terms of like preliminary design review, critical design review, and so on and so forth. So those are, I guess, our formal points at which we have to have information at a certain level, because there
Yeah,
becomes a point where you would carry almost too much risk going forward. But some of the elements where we might go, actually it's worth someone going forward. So if we might have some new technology that we want to try out, or something like that. And so what we might say is, actually we don't quite know exactly how we want that to work or what we want that to look like, but we want to do some work on it, so by the time we get to that point we're a bit smarter about what it does, so we can
yeah,
almost feed some of that back in. Because what we don't want to do is obviously paint ourselves into an impossible situation where you go, well, I want this, but actually it's not feasible, or there's unfortunately
yeah,
money sometimes rears its head. Occasionally project managers like us to come in on time and on spend, such a pain, but as engineers. But and so I think it's really putting around where we're willing to take the risk. Obviously, if we did that with the
yeah,
entire program, and
yeah,
then I had to go to a customer and say, well, on what basis am I
yeah,
saying that? But if you kind of go, well, actually, I'm going to take this to this point, and this is our decision point. We can give you this much time, but at this point,
yeah,
we have to put that line in the sand. By CDR, we have to know what it is that we're doing. So that is our scope for wiggle.
mm,
Doesn't stop, and I think we've all been there, late breaking changes in the requirements because the customer said, oh, actually I'd
yeah,
quite like one, and you're like, oh, good, I had already, oh, good, I'll have to make some
yeah,
changes then. But but I think it's internally being aware of what risk you're willing to carry, and also I'm going to use another couple of buzzwords, but if you're taking something from a previous project, understanding what technical debt that's coming with,
yeah,
and actually what hasn't been closed out. Because I also think there's a real tendency to go, well, that's been done before, and
mm,
you go, and actually sometimes when you lift the veil a little bit, you go, it was done, but it's got
yeah,
these things with it. So I think there's a bit of that about kind of understanding what risk is acceptable, Are you putting your entire program at risk? Do you have a plan B if that doesn't work out? That
Yeah.
sort of piece. And say some customers, as you appreciate, have different appetites for risk to
Yeah.
others, and it sometimes depends on how novel whatever it is that you're
Yeah.
doing is. So,
I particularly like maturity aspects when like measuring requirements and be like,
yeah,
actually just identifying this is an immature requirement
yeah,
that needs some further thought, but we've
yeah,
captured it and
yes,
actually identified, yes, we might actually evolve that, or we're going to proceed
yes,
at risk with that, or
yes.
here's
That's a
how
good
we're
idea.
maturing that requirement. I think it's can be quite useful. Again, it's like one of those things. It's only really useful if actually you do use it in terms of you do have that kind of variance in maturity. But yeah, I think it could be a useful tool.
But I think that's a really interesting point as well, because we've all worked on programs that have been short, and I think we've probably all worked on programs that have been quite long, and also particularly if I think back to my time in the defence domain, some of the life cycles and the durations of some of those programs of work, you're talking decades. You're not talking kind of just a couple of years, and so you run into that interesting piece around you know product refreshes, and
Yeah.
obviously changes happen as time goes on, and I think understanding perhaps where some of those came from, what the rationale for them was, and actually at the point why those decisions were made is really important, right? Because then
Yeah.
you can understand why you're making changes, or whether it's
Yeah.
not okay to make, but like the impact of making those changes. And I think then also that maturity piece also probably feeds nicely back there as well, right? Because you can go, well, actually, I'm now going to maybe make some of my requirements like more immature because I'm exploring
Yeah.
how I want to go forward with this.
Yeah. And give the opportunity to explore without the of feeling guilty that
Yes.
it's a mature requirement,
Yes. Yeah.
right?
Yeah. Yeah.
It's like,
Yeah. Yeah.
yeah. Uh, so again, you've touched on a really interesting point: obsolescence and future-proofing your system. Do you capture any of that sort of stuff, like in the beginning phase, in your requirements, or in your potential context diagrams? Is there any, how do you capture that?
That's a really good question. I mean, because I guess obsolescence, as a hardware engineer by background, obsolescence for me, I always think about parts, like someone
Yeah.
stopped making parts and the like. And then obviously, like you say, you've got that bigger picture piece of like, well, what do things change, or have you as well, and how are things coming obsolete. I don't think I actually have like, oh, I do this. I think
Yeah.
a little dependent, but I think it's something that's interesting. In previous organisations, we've looked at kind of product line engineering. So how do you handle having a product that's going to endure and like varianting and bits and pieces
Yeah.
like that. And so some of the things that I think is probably most analogous to what we're sort of talking about here is looking at where things can change and where they can't change, because there is so where we're happy to accept a variant or a change because the impact can be bounded and understood, and actually where fundamentally it would just be too big for the system. Because I guess part of what you're interested in is going, if this thing changes, what does that ripple through? And
Yeah.
so what we're really and I always impress upon some of the guys that I work with is traceability and rationale. Because if you can capture that, and that's one of the nice things about using some of these formal tools, is you don't have to go, well, it's number one over here, and then I find number one over, you get
Yeah.
some of those links built in. But I
Yeah.
think it's having some of those links and that traceability to allow you to do that assessment. And I say it's the same when you're looking at the product line stuff and the varianting, is you want to understand what change means. And I think if you don't, like you say, if you don't mark that in some way, you can't then see where that goes. But typically, I must admit, I haven't ever sort of gone, oh, that's an obsolescence, like that's one that's potentially be risk obsolescence, but something maybe I
No.
should be thinking about. So I'll take that away and
Yeah.
consider that one for the future, Connor, for
Yeah.
sure.
It's one of the things I've always had, like, support teams like moaning in your ear that they're not engaged in the process early enough.
Yeah.
And actually, it's I don't think I haven't come across like a nice tool that says, oh, you need to consider X, Y, Z, or a method like that. I think it's it's very much of make sure that they're in the room at the right sort of time,
Yeah.
maybe when you're doing your context diagrams, or at least getting them to review the requirements or something
Yeah.
like that, to kind of get them bought into that process. I think
It's like
is really good.
I guess it's a big bit about, and it's one of my pet hates, is like gatekeeping in engineering. You
Yeah.
know, where people won't share information and won't. And it's there's few things in this world that really get on my nerves, and that is one of them. You know, where
Yeah.
people treat knowledge as power, and
Yeah.
I think in engineering. You know, it is a team sport. You have to do it together. You cannot be like, well, that's my, because it doesn't. So at the end of the day, you all want a successful outcome. So
Yeah.
you need to do that sharing. You need to bring people in. You know,
Yeah.
shared knowledge is power, not your own your own knowledge. You
Yeah.
know, so yeah,
Yeah. And that is system engineering, right? Is actually
yes,
making everyone be on the same page with kind of that common understanding of what the end goal looks like.
yeah, for sure.
Uh, okay. What? I'm using one of our stock questions. What makes a good requirements engineer? Or if we're talking about requirements.
Yeah.
What are some of the skills that good requirements are made out of, and what are some of the mistakes potentially made?
Okay, so I think a good requirements engineer actually needs to be able to see across the V, because I think one of the things that I've seen and is that people get very focused on the requirement and what that means, but they don't think about the poor person at the end who's got to prove out that requirement, right? So I think being
Yeah.
able to have that view of, okay, what does this requirement mean? Not only because in terms of what the customer or the particular stakeholder needs
Yeah.
the system to have or to do or what have you, but actually how am I going to demonstrate that at the end? How am I going to prove to someone that's actually happened? Because, you know, I've worked on a number of programs, in this life and previous, where the verification piece undertaking is massive, right? And actually can take,
Yeah.
I mean, people always say like the design phase takes a long time. Well, the verification phase can take, and so if you come up with if they haven't, if someone hasn't got one eye on where this is actually going, you can almost kind of tank your program before you start, or things run late, the verification piece gets squeezed, and you have to do more work in less time. And it's really important then to have a very clear understanding of where that needs to go, and how that's getting get sort of signed off. So I think, whenever we write requirements, we write a requirement and we write a verification statement that goes, method that goes along
Yeah.
with it. So and I'm talking beyond the IADT, like the full, like might only be a one-liner at this point, but it's at least a nod to where that is going. So that's an important one. So having someone who can look at what do those stakeholders need, but also what does someone down that line gonna need to better do that proving. And I think also someone so you can see the wood for the trees, right? Because
Yeah.
you can, on complex programs, right, you can end up with like thousands of requirements, and you need someone who can, I guess, focus on sometimes the minutia, but also come back up and go, in the totality, does this actually tell me what I need? Because I think one of the biggest issues, and I don't think I have a apologies, I don't have like a one-liner how to solve this problem, but one of the
Yeah.
biggest issues is knowing the right level to take your requirements to, right?
Yeah.
Is getting it to a point where there's enough definition, but not so you're actually telling someone how to implement it down to a level that leaves no scope for creativity and doing something in a different way. Because otherwise, your requirements engineer by de facto designs your entire system and doesn't let those
Yeah.
specialists do that work. And so I think it's a real trick to how you do that, and like not putting in sort of pointless requirements that like it shall have one of these. Well, great, unless it's telling me
Yeah.
something that I wouldn't already know. Why is it there? Because every requirement obviously costs money, because you've got to do some kind of verification, someone's got to sign off on it, those pieces. And then the other one is, and this again is a tricky one, right, is knowing how to elicit. So if I said I wanted it to be easy to use, great, but what does that actually mean, and how do you actually articulate that in a way that's not subjective? I
Yeah.
think that's the other thing, is someone who's aware of what is or isn't subjective. And I know that's really tricky, because that easy to use is like an easy example to give, because what my definition of easy to use and your definition of easy to use is going to be totally different, right? But it's knowing some of that, and actually knowing when to go back and say, I need some more there, or we need to provide something a bit more concrete. So, but I say these are all tricky things. And I think, unfortunately, some of it just comes with experience.
Yeah.
You do it and you
Yeah.
go, next time you go, oh, okay, actually, I wouldn't do that again next time. That didn't quite come
Yeah.
as I was expecting. But I think those would be the key parts.
Yeah, and the experience point is a really good point. And actually, we spoke about previously before the call was that it's about sometimes about creating a safe space for
Yes.
beginners
Yes.
or young engineers or early career engineers to
Yeah.
essentially make those mistakes in a right environment. And I think
Yeah.
that's the beauty of grad programs and stuff. If you can
Yes.
get a grad program that will allow you to run with a mock project or
Yeah.
make those early mistakes early on, that you kind of you can
Yes.
come around to the second time with a little bit more experience in your cap type thing.
Yeah.
Yeah,
And I think as well, it's also on those engineers with some experience to impart some of that experience with reasons. Does that make, rather than just being like, it is this, it's
yeah,
this, and this is because, and here's the funny anecdote that goes why this is and to bring some of those examples to life, because I think, especially when we're busy and so on and so forth, it's very easy for sort of experienced engineers to sort of say, this is what it is, and we do it like this, and to perhaps sometimes forget to give some of that context and that rationale as to why, because you don't want everybody just repeating the same mistakes forever, because that just eats up time. There's a time and place, I agree, for, like you say, learning and having the opportunity to make mistakes, and to also know that making a mistake is okay, as long, and how you then come back from said mistake is a really important
yeah,
lesson. I think there's also that piece of, if there's really fundamental stuff, why waste everyone's time going around that again?
yeah,
Why not? It's the specials, the novels, the differences that you want people to learn from, not the
yeah,
standard like don't do this or do this, or but I think it's that context piece. We
yeah,
all like to, if we're getting told to do something, we all like to understand why we want to
yeah,
do it. It makes it more accessible and tangible, I think. So
yeah. That actually takes us on our next point really nicely, is
okay.
that team aspect.
Yeah.
So I love your quote in one of the blog posts you wrote recently, was that engineers are naturally team players, and actually making that happen. Requirements engineering in a team, you get different flavors of people writing different requirements and all that sort of
Yes.
stuff. So how do you control that, or how do you make it common, a common requirement set that looks the same, and
Yeah.
how do what makes a good team, a good requirements team
Yeah.
versus a bad one, a
Yeah,
bad
I guess. Yeah, no, and that's a really interesting point. I mean, like I've sort of touched on it before, we're all engineers, but we all talk a slightly different language depending on where we've come from and what our backgrounds are, and so on and so forth. And even within people who've done sort of similar jobs or similar roles, there's still that difference just based on life. We all come from a different place of different mental models and the like. And I think,
yeah,
like I say, engineering is a team sport. You can't do engineering on your own. That doesn't stop personalities. That's always an interesting factor. But I think if,
yeah,
if you remember that at the heart, then that really helps. And I think when it comes to requirements, and we've had this, across my time and across my various roles and things, we've not only worked with other UK companies and other UK clients, but also international clients. And sometimes you're doing, and so I like to think about this as similar to sort of how we look at, even when we're just doing UK based ones, is people's terminology and vocabulary is different. And so one word for one person is a different word for someone else. And so what we try and do, and sometimes with varying degrees of success, is set up a bit of a dictionary or ontology at the beginning of a thing and be like, right, let's just agree some of those key terms and phrases, the ones
yeah,
that could trip us up. Actually, let's just agree what some of those actually are. So we have some definitions, and it might feel very noddy to do, and everyone goes, oh, yeah, yeah, yeah. But it's funny what comes out of some of those conversations, and
yeah,
sometimes you can be in violent agreement with someone but not realizing you are, because you're just using two subtly different words, and
yeah,
and so I think it's really important to spend that little bit of time and going, okay, if we're going to talk about this, let's all just agree, just some general terms, because you don't want to waste that time violently agreeing with each other. You want to be getting into those sticky ones of like, oh, well, it should be this or that, and actually putting that expertise to use in those those problem areas.
yeah,
And so that's a really key one. But I think also, everybody has an opinion. It's a fact of life, and requirements
yeah,
elicit opinions like, no other thing I've ever seen in my. You give someone, I think it's always one of these things. You write something, if you have a blank piece of paper and ask someone what they think, it's difficult. You write something down, you give it to someone, and suddenly their red pen is out, and and so I think.
Yeah.
Being a requirements engineer or being involved in requirements, I think there's an acceptance that you are going to get views, and some of those views may
Mm.
not align with your own. But I think it's having that understanding of, generally people just want it to be right. They want to see the thing go right, and I think it's being able to take maybe sometimes those conflicting and different opinions and actually almost mediating. And I say this a lot in system engineering. A lot of the
Mm.
time, it's that communication, actually just bringing people to the same point, is actually as much of a skill as the piece that goes around it. And I think sometimes those soft skills are underplayed, but actually, really, system engineers, if you think about it, you're talking to different
Yeah.
disciplines, people with different backgrounds, different priorities, and you actually have to do some of that sort of smoothing and that, okay, how do I phrase this in a way that I can elicit agreement from people. So I think requirement
Yeah.
engineers are on the sharp end of that, because effectively they are the record keepers of what's being
Mm.
agreed. And so I think a lot of it's about finding a way to do that so that the intent is captured to the design and the work can go forward, but also you smooth the waters with perhaps the people
Yeah.
kind of upstream as well.
Yeah.
So I think there's obviously a level of rigor and attention to detail and that piece, but I think also being open and able to facilitate discussions is a really probably
Mm.
important skill as well.
I, I think it marks the difference between potentially a junior engineer and actually a senior or a lead, is that they're very good at being able to facilitate that kind of smoothing process that you talked
Yes.
about,
Yeah.
where actually they can kind of lead the horse to water and knowing that they're going to have different opinions, but
Yeah.
actually using tools such as, defining a methodology or defining a terminology and an
Yeah.
ontology and all that,
Yeah.
and actually bringing a common understanding and then actually being able to kind of entice and make sure everyone's heard and then have a
Yes.
good requirement at the back. I think
Yeah.
that's a skill. That's not something that you can just learn, overnight. I think that takes time.
No, and I think it's that. As I say, like a lot of it is bringing people round rather than being like,
Yeah,
this is what it is, bringing people around to the idea so they understand why. There will be some things you just have to say, like if it's a regulatory thing, there's no amount of smoothing. It is what it is and we have
no,
to just deal with it. But there are things, I think there's a lot to be said for that, and I think you're right. I think it's a skill that's learned, but I think if you go in with that openness, you can find good examples and you can see how that is done,
yeah,
um, for sure. Yeah.
yeah. Okay, zooming out.
Yeah.
How do we, looking at the bigger picture of programs and actually delivering stuff, which we're there to do, not just
Yeah.
kind of get stuck in the weeds?
Yeah.
How,
Occasionally. Yeah.
yeah, how do we use requirements to then like deliver a program? Like kind of big picture. They're defining what we need, but where do we use them later on, and how does it actually help us realize our product?
Yeah, so I think a lot of it. So if I was to go to like customer or client level, is really setting that expectation so that when you get
Yeah,
to the end, you don't have that disappointment. And I think being able to kind of incrementally show how you're fulfilling what you said that you would fulfill for them, and
yeah,
not go for that big bang like, hey, there's just a demo at the end and I'll wash my hands of it, and if you don't like what I've made, tough luck.
yeah,
So I think it really helps facilitate part of that customer journey of saying this is what and also having those discussions where things aren't quite as you had planned them to be, then that some unforeseen constraints might come in and that piece. So I think you can use them as a good vehicle for conversations with customers across the entire life cycle, and also it's a really, I've worked with a number of clients who particularly like to see the burn down of requirements across a
yeah,
project. So say you start with 100 requirements and you say, well, 25 of them get done by analysis, technically by CDR, then they should all be closed out. So you should be able to say, look, I'm on track, and then 50% will be done, and so on and so forth. And so I think it's a really nice way for a customer to get some insight into how things are going, and that piece. So I
yeah,
think that's a really useful way to use requirements beyond obviously making what it is that they would like. And I think I think if you can get that hierarchy of requirements right, it allows you as well, because the system engineer, if you think about a big program, there's lots of different elements to it, subsystems and the like. And you may be superhuman and be able to remember all the things at once, but I certainly can't. I have to,
Yeah.
And so I think it's a really useful vehicle to facilitate those discussions with those subsystems and perhaps some of those particular specialist domains and disciplines. So
Yeah.
kind of having that snapshot that you can take and dip in and say, well, how are things going? Did we meet this? Have we not met that? And so on and so forth. And
Yeah.
I think you need to be cognizant of them across the entire. I think there's a thing of like, well, I did them at the beginning and then I check my verification at the end and I ignore them in the middle. But I think
Yeah.
if you don't follow that along, you won't pick up if you get a deviation somewhere along the line, actually how that filters up, and you could
Yeah.
catch things earlier than you might do if you just concentrated at the system level. So I think there's that piece around using it to monitor progress, also prove out that things are going in the right direction,
Yeah.
and actually that you're on track as well.
Yeah.
And you might find, I mean, you might also find as you get through, you haven't done enough requirements work, right? Because you might get to the point where you go to someone, I want you to go do this widget, and they go, great, I can't
Yeah.
actually do this because you're not giving me enough. So I think there's also that it's not a wash my hands of it and
Yeah.
I ignore it, So I think they're the sort of the key bits for me is, obviously there's that real upfront bit and then the V and V at the end, but it's that watching it through the design, are things trending in the right direction? Because you might
Yeah.
find, like you say, you've made an assumption that and someone else has made a different assumption and things aren't quite gelling. So
Yeah, that's really good, and I like it as well. The analogy of like actually it helps us get paid because it gives us a baseline to prove that we've actually
yeah.
done it.
Yes.
And here's the evidence to say that we've done it. It's nice.
And
So
oh, sorry, I was going to say, because also where I've worked on safety critical programs before,
yeah,
it's incredibly important, because ultimately, a lot of the time, you're having to, as the requirements sort of engineer or whatever, having to say to those higher up in the company, yes, this is going right. Yes, people are doing what they should have
yeah,
done, and yes, this is something that can be signed off because they're looking to you to have gone. Have you gathered the compliance evidence? Have we got the right set of requirements? Can I tick
yeah,
this product? And so it's actually, it can be really quite an important, not it's not an important, but like it can have a added level of rigor where you have to be very confident in what you're saying beyond pleasing a customer or not. Actually legally,
yeah.
does it do what it's supposed to do as well?
It was actually my next question.
Oh, sorry.
Being in
Yeah.
space, it's a
Yeah.
heavily regulated industry. So,
Yeah.
do you use them for your qualification and acceptance? Is there any nuances in space that you might, use more, use requirements more because of that regulation and safety aspect? Or
I think actually, I mean, I say space does have it, and we are finding that particularly in things like the launch arena, there's a lot
yeah,
more. They're pushing a lot more requirements out now. There's a much bigger awareness. So if I take launch as an example, launch providers want to know that what you put on their rocket is not going to have any adverse effects. So that pushes out
mm,
a lot of requirements, and so they are particularly like, I need to see the evidence, and it has to be done a particular way, and the I's dotted and T's crossed, and things like that. Same with some
yeah,
of the regulatory bodies. We're all using communication, so RF communication from space. Well, sorry, some are using optical, but you've got the whole kind of RF,
yeah,
links from space to ground, and that spectrum is heavily used in some areas congested, so you have to be able to demonstrate as well, like, I'm not causing any problems, I'm not going to interfere with anybody else in these bits and pieces. So there are definitely pieces where that is an issue. I work very much on the unmanned space side, so that is,
yeah,
so there are regulations around collision avoidance, deorbiting, those bits and pieces, but you don't have the same level of rigor if you were to, for example, jump across to manned missions, and that
yeah,
where you've got to demonstrate that you're not going to hurt anyone, injure anybody, and those bits and pieces, and it's fit for human use. And so I think it's a bit kind of, there is a level of rigor, but
yeah,
it's not as rigorous as some of the other areas. So when I've worked in some of my previous careers, where roles where I've had to been working on safety critical systems, that is a whole different level of rigor. And I think in some of those areas, so yes, requirements and that verification form is a really important piece of that. But a lot of that
yeah,
then comes also down to the processes that are applied. And if you don't have that golden thread that goes all the way through, you can't bake it in afterwards. You have to like do things in a certain way. So space is different if you work maybe with an institutional body like ESA or NASA. There's perhaps a different level of rigor to if you're doing some of the lower cost kind of missions and stuff. So it's very much scalable depending upon what
Yeah.
you're up to. But I say if you looked at manned or if you go to anything that's safety critical, it will jump right up.
Yeah, that's really cool. Okay, opening the floor now a little bit to just general early career advice. So, obviously the school is dedicated to try and share, lessons and tips and tricks with kind of the early career system engineers. Is there any in particular that you'd kind of like to call out that kind of made you successful, in your career transitioning up from kind of junior and that kind of senior role?
It's a good question. I think, and I think it touches upon something you mentioned earlier, like take advantage of any of the graduate schemes and the opportunities that come along to do something a little bit different. I remember when one of the things I looked for when I left university was to go to a company that offered the ability to try out different things and to get some experience, because you spent however many years studying one thing and the world of work is like this, right? And suddenly this door opens and there's a whole bunch of things you've not even heard of, let alone know whether you want to work in them. And I think sometimes can be very reticent to try different things because we become comfortable. And I would say, when you're still early in your career, you're saddled with less baggage, right? So the longer you spend in a role and you just you become the go-to person for something, and you lose some of that flexibility to move around and try different things and have a go, because there becomes a slightly different level of expectation that goes along kind of with seniority and the like. And so I would advocate, if you have the opportunity to try out different things and maybe try things that stretch you, even if it's like, actually I do my main job for 4 days a week and I have a day a week that I support something else or that kind of thing. I cannot advocate getting different experience enough, because the only way you'll know whether you really like something, dislike something, what resonates with you is to have a go. And so I appreciate, totally acknowledge that it's not always just have a go at something. That doesn't always work in the commercial world, and there's that thing. So if there's opportunities perhaps to get involved, if you can't do it through your actual job, other opportunities maybe through some of the institutional bodies or something to have a go at things, or to at least get an awareness and appreciation of other things, because there's a lot to be said. I think my confidence over my career has grown because I've had the opportunity to try things, and I've started to get a bit of like a CV behind me. I'm like, I tried that, and not everything's gone perfect. I'm not going to sit here and be like, everything I've ever done has been wonderful. Some of it hasn't, and some of it I cringe at, and I thought, golly, if I did that now, it would look completely different. But I was, I had a go, I've learned things, and I've been able to take that forward, and I've not been, I guess, scared to learn things and to go actually, and to try something different. So I think that's one of the key things for me is about having a go, trying to push up, but also I think sometimes there's this tendency that everyone feels like they have to climb up and have to climb the greasy pole and have to be, the top of and actually if you say, let's use requirements engineering as an example. If you do requirements engineering and go, do you know what? Hey, this is great. I love it. Happy days. There's I think there's sometimes this push in there that not everyone has to be in charge of everything, and not everyone has to kind of manage everything. And if actually you're really happy doing these roles, then great. But I think there's a lot to be said about is keeping yourself open and keeping yourself. Technology moves on fast. Though admittedly in some industries it doesn't always feel like it, but technology does move on fast. So I think even if you reach a point you go, do you know what, I'm happy here, is keeping yourself fresh in that area. So I think there's two. One is getting experience across, and then if you do find an area, going, well, okay, I'm staying in this area, but I'm going to keep myself up to date in that area, I think is good.
And having that curiosity to explore things, isn't it? And kind of, be a continual learner type thing, isn't it? Even when you're old, or 60 plus, kind of greybeard type thing is the term in the UK.
Yes.
But
and then I think also being happy to reflect it back to people who have come up. I think it's interesting, and I have to remind myself of this when we get junior staff and stuff, is what it feels like to be at that point of going, oh my gosh, what am, this is quite a thing, and so as we go up, trying to remember what it was like to be there, and actually what would have been useful, what would have helped, that kind of piece as well. So
Yeah, that's really nice. Good. Well, thank you very much. How can potential students or anyone reach out to you or ask questions or connect with you? What's your main LinkedIn or?
LinkedIn is, yeah, you can find me on LinkedIn. I mean,
Yeah,
obviously you can put my details up, Connor, with that, and ping me a message on LinkedIn. That's not a problem. I'm reasonably good at checking my LinkedIn, and then if need be, I can always pass
yeah.
on my email contact details through that if it's appropriate. So
Good. Well, thank you very much, Vicky, for joining the podcast. We hope to see you on again soon.
lovely. Thank you very much, Connor. Thanks for having me.